Good afternoon, everybody. Just to show that it is a small world, I was born in Australia, and perhaps the reason I'm here also was because of I should be the house of immigrants. Certainly for the Dutch group, maybe the Danish group, and some of the German group, my people were Frisian originally, from Schleswig-Holstein, from a small town called Dagebel, except they were not very good builders of seawalls. And in the mid-1800s, around 1853, one good storm took all of their land. So they ended up part of the Great Migration, and by luck, the free ship that they got on from England ended up going to Australia instead of going to America. And then I end up living in Brussels for many years, and then finally I live now in the US. And I've decided to do half of my presentation this afternoon in Netherlands and half of it in Danish and a little in Swedish. And then I heard such fabulous translation, I decided to do it all in English because I didn't want to be shamed. Again, thank you for allowing me, particularly my Swedish hosts, to be here. In a small amount of time, I'm going to try to give you a sense of what's happening in America. It's a time of enormous change in energy, in government, in public perception, so there's no way I can do all of this. It would be like saying what's going on in Europe and trying to condense it. But I'll do my best to give you at least an overview, and also to try to compare it a little bit to some of what I've heard this morning about SESAC and some of the objective, because you're going to see some things which are very, very familiar to you. We will see. There we go. So I thought if I tried to break it into 4 areas, what is making the US change, and is it real? Because I think in Europe you've seen changes in the US before and they haven't been permanent. But I think you're going to see now changes that will be forever. What's happening in the marketplace? You know, where are the business opportunities? Where are some of the best practices, and where do we go from here in the US market? Environment, what is causing the big changes in the US? You know, environment, I would say, is of second importance. Economics is of number 1. Now, I think that's also true in Europe. I think that the question I asked this morning about carbon tax, you know, would we have seen in Europe the changes we've seen if there had been no tax increase on carbon? And I think the answer is no, we would not have seen the change. We're seeing the same thing in the US. We're seeing a lot of increase in the cost of energy. And it's that increase which is causing suddenly a lot of interest in conserving. When energy was cheap, nobody cared. It's getting more expensive, everybody matters now. The environment does matter, and it's driving public policy. And you really see also public opinion. When energy became expensive, at least expensive in American terms, before the financial problems of the last 2 years, people became very interested. And remember that when you live in America and you deal in US dollars, you really did see doubling of the price, which is not true here. As the US dollar changed and got weaker against the euro, you didn't see in Europe the same incredible increase in the price of energy. So energy in the US doubled, and the public took notice, and the politicians took notice. One of the comparisons that I try to show people is this chart, and I understand this chart perhaps is a little difficult to understand, but what I try to do here is compare the GDP per head of population of various countries in the world. How good is a country at producing wealth, and how much kilowatts per capita? How does it produce that wealth? And you get some very interesting information. First of all, here is the US. It has a very high output. It produces enormous wealth, but it does it by using enormous amounts of energy. If everybody in the world used energy at the rate Americans use energy, the world could only support a little over 1 billion people. So the US uses 25% of the world's energy, but it only has, a very small percentage of the world's population. One of the things I also try to explain when you look at the world average down here, it takes only a very small increase in energy use in China and India to produce a dramatic change in the world. And that is what we saw a couple of years ago. Another very complex graph, but one good for later to look at. It's important for those of you who want to understand why you're seeing certain policies happen in the US. This is how the US produces its energy in total. Nearly 40% of the US energy, this is not just buildings, this is buildings and transport, comes from petroleum. Nearly 25% comes from natural gas. Natural gas is a very large use in the US for the production of electricity. Coal makes up nearly a quarter. The US has very abundant and cheap sources of coal. Renewables now, and this is mainly hydro, growing very quickly, is only 6 or 7%, and nuclear is 8%. When you look at where is it used, 30% of all energy in America is used for transportation. Somebody said this morning, we have an ongoing love affair with our car, and this is continuing. Maybe the car's getting smaller, but we still love it just the same. Industry uses 20, residential electricity uses 40. I show this graph to say this. Where you're going to see the really big impact is this. You will see major push towards removing coal from electricity, replacing coal in electricity. You're going to see major changes in reduction of petroleum in transport and natural gas in residential. So use that graph at another time when you look at the headlines in America to understand what is really driving the cost position. This is the other thing that's driving it. This is a chart that shows the actual cost, the residential, the consumer pays for electricity. Now it's low compared to European prices. So I'm sorry I have this in dollars, but with everybody in this room, maybe that's the easiest. I didn't do it in euros, but here it is in dollars. The average price for many years, nearly 15, 20 years, was extremely stable. The average consumer in the US paid 8 cents per kilowatt hour. It started to rapidly change back in 2003. It's now increasing at about 10% per year, and it's predicted to keep increasing at 10% per year for at least the next 10 or 15 years. That means that the US will start to see its electricity prices double every 7 years for the next several years. That has driven an entire change in the way consumers think about power. It's gone from very cheap to more expensive to starting to approach European rates across time. So within 7 or 8 years, the US consumer will see the same sort of prices that a Dutch consumer or a Swedish consumer, perhaps not a Danish consumer, will pay. And the question asked before, but if things become more energy efficient, will we see excess capacity? Not in the US. The US is growing as a country now strongly, both its population and its economy. We would predict that we'll continue to see increases in the use of electricity 4 or 5%. In the south of the US, where the delegation here is from, in Savannah, we're seeing the population move south in the US. Less heating, more cooling, more electricity, very humid in the south. So we're seeing population and electricity growing at 5 to 7% per year. So we have enormous demand, we have increasing prices, and suddenly everybody cares a lot about conservation and cost. We've also had a change in president, in case anybody noticed, in Europe. And here is my one page to try to explain American politics in 6 lines. In fact, I've been ambitious enough to tell you not only what the current administration will do, but what I think the next one will have to do as well. And here it is. Under the Bush administration, George Bush administration that was there for 8 years, the number one focus in energy was national security of oil. It was all about liquid fuels and how to produce alternatives to liquid fuels, either by economic means, political means, but it was about security. The Obama administration is very, very different. They focused on conservation first, reduce the amount of energy used in the country, and then start looking at renewables. And so you see billions of dollars being spent on weatherization, public housing, new construction, building codes, very much the sorts of things that the SESAC project are focused on. You're seeing a proposed 50% increase in fuel standards in cars. So everything is pushing down demand and then supplying it. Where do I think we go next? I think it'll be competitiveness. It's not enough to be able to replace fossil energy with renewable energy. You have to do it at a lower cost. And I think that the US is very inefficient. The US wants to be both efficient and cheap in energy. And if it can do that, it will be a very difficult competitor on the world stage. And so I think the next place will be cheap renewable energy, not just renewable energy. And the US is spending about $80 billion on finding ways to produce renewable energy at a lower cost. Market view. And this brings me to some of the similarities between what's going on in the US and what I'm seeing in Europe as well. The US is very good at marketing, and unfortunately, everything now is green. And the public is getting a little tired of things being sold as green when they have nothing green about them. And so there are a series, just as there are in your projects, of measurement and verification to ensure that when somebody says it's sustainable and efficient, it truly is, and that it's measured by an independent third party. There are national programs and there are local programs. And for those of you who get involved in the US market, you'll be exposed to all of these. But the two most important ones are these. There is a voluntary, this is not a law, this is a voluntary program called LEED. You'll see it as LEED, Leadership in Environmental Design. It's a point-based system. That is, you take a building and you rate it on about 30 different categories: energy, air quality, construction methods, how the building was actually built, were the materials recycled, were they purchased with materials locally produced, was rainwater and runoff properly controlled, are there ability for employees to either use public transport or bicycles. I don't have any photographs of me on bicycles, but I did in the other one, but then I had to change the slides before. So LEED is a points-based system where many sustainable questions are taken into account. Below that, there is what you'll see in the US as the Energy Star program. The Energy Star program is something which rates products like a refrigerator or even a whole house. And what it measures is how efficient is it compared to another house. So it's like, what is the fuel economy of your car? You now can measure what the energy economy is of your building. So they are the two programs, a points-based system which takes in many things and a measurement system underneath it. And here's how you'll see them reflected in the US literature. On this side here, let me start first with Energy Star. Energy Star has a rating system. A house built to the current building code has an energy rating of 100. Each movement of 1 up or down means 1% better or 1% worse. So if a house rates 65, it means that it is 35% more energy efficient than a new house built to code. The current average existing house in the US is 130. So the current stock of existing homes are 30% less energy efficient than a new home. For a home to be branded Energy Star, it must be 75 or below. To get below 65, you need to start installing solar. You can't do it through design only. To get to 65, you have to have a house that is so airtight that it requires forced ventilation. So this is a measurement system. The lead system then, you measure it, but then you take into account all of the sustainability questions. And depending on how many points you score, you can go from bronze to platinum. So you'll see a building can be awarded a different level of rating. It's marketing perhaps, but it gives you an idea of one building to another, how efficient. So this was started 3 or 4 years ago to give you an idea of how it's progressing. The government mandated that all federal buildings, their own buildings, that includes all military bases, all hospitals, and remember the largest owner of real estate in the world, the largest single owner of real estate is the US government. And inside that, the largest owner of real estate is the US military. And so they decided that all military bases would have to meet the standard. And so it's driven the market. Many universities are now attaining these goals. And in the last few years, and you can see here from 2005 to current, 385 million square feet have now been certified as LEED within just a few years. That amounts to a little over 3,000 individual buildings have been certified, and it is growing at these sorts of rates. This is all over in the US. This is in total, these numbers. So as a total percentage of the US buildings, it's small, but it's growing very quickly. And you can certify either a new building or a renovated building. So you can do a renovation. You can't simply certify an existing building without doing anything to it. It has to either be renovated or it has to be built new. So it's accelerating very quickly in this new market. I thought I would try to compare, if I go down a level now and look at what are the actual requirements, or what are they trying to achieve, so that you can compare that to some of the work that you've seen in SESAC as well, and in your own countries. They started with best practices. 21 of the largest government agencies in the country all signed a memorandum of understanding that said they would try to meet these new goals to create a new market in the US. But this is not a law. This is a voluntary program, which is very typical in the US. It's very typical to at least try and get people to do it voluntarily. The idea being, if they do it voluntarily, they do it because economically it works, not because they're forced to do it. But that's just part of the US political process. When you look at a building now in the US, either new or restructured, you're going to see very similar steps involved in how you're approaching it here in Europe. First of all, the design principles. You know, are you designing the building in the first place to have a long life, to be using good quality materials, and to have low environmental impact? In energy performance, it must be 30% better than the current building code. Now, each year the building code gets tougher, but the goal stays the same. So each year it is getting harder and harder to achieve the 30% reduction because the baseline is being lifted each year. Measurement and verification are critical. Independent, third-party experts have to measure heat rates, air tightness, equipment installation to make sure that they've been installed correctly. Water is as important as energy. In most parts of the US, water is becoming very scarce. The population is moving south, and in fact, in my family home, which is in Atlanta, which is in the south, I pay nearly as much for water each month as I do for electricity. Water is becoming expensive. And what is the largest component of water cost? Energy. So they're linked. They're linked together. So in the US standard, you have to save water as well, and you have to save it a little bit less, but 20%. Outdoor water has to be reduced 50%. So you either must collect the rainwater, or as Mayor Johnson was saying this morning, reuse the grey water to be able to reduce consumption. The indoor environment. It's important not only that we save energy, but that the health and welfare of the inhabitants of the building are looked after. And so indoor air quality is an important piece. Ventilation and thermal comfort. By thermal comfort, they mean that the building cannot vary more than 3 degrees Fahrenheit from its set point. So anywhere within the building, whatever the temperature you set it at, between 68 and 78 degrees Fahrenheit, it has to be even and comfortable. 4 Celsius, 24. Yeah. Moisture control, relative humidity has to be able to be controlled at less than 60%. Mold and mildew in the US is a big problem because it's not only hot, it's humid. And so being able to reduce moisture destruction and increase indoor air quality is important. Daylighting. There are specific regulations to reduce the amount of electric lights. Now again, in most places in the US, you have abundant daylight. And so this is practical. I mean, I don't think I would like to live in the north of Sweden and be told that 75% of my light has to come from daylight. Right? There would be long periods of sitting quietly in the corner, I think. Low emitting materials. So VOCs, volatile organics, have to be reduced. And also protect the air quality during construction so that the workers who are building should not also be exposed. Now these seem perhaps aggressive goals, but they've been well documented, and in general, I would tell you that the cost of meeting these is considered to be about 4% higher than building without them across the entire project. Because what they're finding is that even though it costs more to do this, it costs far less in problems and claims and poor installation. So when you take the total cost, it seems to be about 4% more expensive, and that's a cost that people are willing to bear. The other one has become recycled material. 10% of the content of the building, that is the materials, the concrete, the wood, the finishings, the floor coverings, must come from recycled building materials. There are extra points for using environmentally sensitive and materials like wood bamboo. You can get points for doing that. And construction waste, you must recycle or save half of the waste. So it has to go back into the next project. So these are the key, and you'll see this if you have a look online and look at LEED. You'll actually see examples of this. As I said, there's about 35 different categories. Each one has a certain amount of points depending on did you meet these and how well did you meet them. So for instance, if you get 8% of recycled material, you would get 1 score. If you had 15% of recycled material, you would get a higher score. So it's a method of balancing energy, water, environment, and also the occupants of the building, and being able to certify the building. An interesting thing has started to happen. Employers who have their buildings certified are showing less employee sickness. They're showing better retention of employees, and they're showing their ability to attract employees, particularly people who are younger, is much higher. There's also evidence now that these buildings are selling at a higher price and renting at a higher price. So people are seeing an economic return from making sure that they certify their buildings. So perhaps some summary points. So in the US, we're seeing this both a points-based system, balanced, a scorecard, perhaps, report card, and measurement. They're focused both on new construction and renovation of the existing stock. Generally, they're looking over the next few years to reduce the energy consumption between 10 and 25% from whatever the current average is. So they keep moving the bar up each year. They're investing heavily, as I said, nearly $80 billion in research to not only make this possible, but cheaper. They want to be competitive. Focus on weatherization, lighting, and combined heat and power, although there are almost no district heating or cooling systems. Although I'm now involved in a few of them, a few first ones, primarily on military bases, to start using them as example. There is much to be learned from Europe in the US, particularly on district cooling, on using waste heat to produce cooling and then distributing that. That market perhaps is $100 billion business opportunity for European companies to come in to the US. And I think I present this certainly to this group. You may have no idea how valuable your knowledge is in the US market. You know, we're talking about things here that have just started in the last few months. I believe that the US will be the largest market in the world for renewable energy for 2 reasons. It uses the most energy, and it uses it so badly today that there is the biggest opportunity for improvement. And so that opportunity is really now for people to start coming in and market your products and knowledge into the US. The military is being used as a way of demonstrating it, and for those of you who pick up this presentation later, I've put some web links in there for the Department of Energy and the military, which gives you 50 or 60 case studies of where this has actually been done and the values, how much energy they've improved and how much money they spent on doing it. For those of you who missed the Mayor of Savannah's presentation this morning, just a couple of slides. If you're going to this is really more of an advertisement than anything, but that's okay. If you want to come into the US, we have the perfect place for you to do it. The partner technology city to Växjö here is Savannah in Georgia, located in one of the fastest growing areas, which is in the southeast. It also has some of the best places to drink beer you could possibly imagine in the sunshine. We welcome you in about February. I want you to think of Savannah on the 1st of February and think, I need to visit with Ross and drink a beer. In that area, we are rural, very much like Europe, one of the oldest areas in Georgia. We have many benefits of being there. It's a friendly place to launch your business. And we have a lot of people who would be willing to help you locate your energy efficient business in that area and then start branching out across the US. We have tremendous ties into Western Europe with one of the largest ports now in the country. And it is perhaps the most European city of all US cities. It's a city where you can walk, it's safe, the people are friendly, and the beer is either cold or warm, depending on where you come from. So where to from here? Again, for people's later interest, just to give you an idea of how much the electricity rates vary. This is a chart, and you'll see in this chart that the electricity in the US goes from a low point of around 7 US cents per kilowatt hour to a high of about 17. So there's a tremendous range. And that range really depends on both how is the energy produced. In the south, it's primarily produced from coal. In the north, it's now predominantly produced by natural gas. There is some nuclear as well. And then there's places like California and Texas where a lot of biomass is now used. Biomass in the US costs about 12 or 13 cents per kilowatt to produce based on our wood prices, which are half the price of European wood prices. And wood is abundant. In Georgia alone, we have 10 million hectares of pine plantations producing biomass. And several million tons of that is now being exported, particularly to Holland, Belgium, France, Denmark now, and some to Sweden in pellets for local. So in fact, when you switch your light on, and these lights, well, not these ones because we have daylighting, but increasingly the electricity produced in Europe is produced from biomass made in Georgia, which is a little, to me, like selling snow to Eskimos, but that's the way the world is now. Starting today at around 10 cents per kilowatt, if I simply continue to grow the electricity price in the US at the rate that it's been growing, we'll see European prices about 8 years from now. So I would start thinking, what technologies worked in Europe and at what point did they work? Because many technologies in Europe and a lot of public policy kicked in when electricity hit about 14 cents per kilowatt. That's a couple of years from now, and so we expect to see a lot of those technologies viable in the US market. One more complex graph to leave you with, but it's an important one to look at later. What this shows you is how much wealth a company produces and how efficiently they do it. That is, how much energy does it take to make $1 of GDP? And this is the really good news for Europe, the bad news for the US, but I tell you, I think that the US is waking up to this. Today, most of the people sitting in this room have economies that are roughly equivalent to the US in wealth, perhaps a little lower, but you're able to make that wealth with half as much energy as the US does. That's what this graph tells you, that if I'm sitting over here, I use 160 units of energy for each dollar of GDP. If I'm in the US, I'm half as efficient. That's a big problem for the US. So the US used cheap energy to be a global economic power. And that was great when energy was cheap. But energy isn't cheap. And it's not going to be cheap. And so the US is going to have to not only move to renewable energy, it has to halve its consumption of energy for each dollar of GDP it makes if it's going to continue to compete with Denmark and Sweden and Germany and France on the world stage. And I think that's what's caught the politicians' attention. If it's not enough to be renewable, you have to be efficient, inexpensive, and renewable to win. I think that challenge is now on, and we have political will and cultural will in the US now to change and change dramatically. So I want to thank you today for having an opportunity to speak with you and look forward with you all visiting us in February in Savannah. Happy to take a few questions if you have any. And again, the presentation will be available later for all of the detailed slides.
Thank you, Ross. Interesting. Do we have any questions? Yes?
Yes. The reason I mentioned February is because I think it's the coldest, darkest time in Europe, and I just want everybody to come visit us because it's one of the most beautiful times in Savannah.
Thank you. We appreciate that.
That's all right. I just want to remind you all of that.
Yeah.
We can do that as well.
Yes. It's hard fact to present. I mean, a 10% increase of energy costs every year now. We predict that.
Correct, and there are some really good basis for that. The U.S. stopped building a lot of electricity generating facilities 10 or 15 years ago. So its current energy is very inexpensive because the plants are old. They're already written down, their value. They were built in times when environmental regulations were easy. So today, if I'm going to build a new coal-fired plant or a nuclear plant or a biomass plant or a gas plant, it's not 6 cents. I mean, the replacement cost is 12 cents. And so suddenly, to meet all of these new demands, just the natural replacement cost has jumped up. On top of that, we're starting to now see there is a bill passing through the federal government which talks about a carbon tax at about 2.5 cents per kilowatt.
Okay.
There are green credits. So suddenly we're seeing that's where it's coming from. It's environmental, new capacity, and policy.
Yeah. 2.5 cents is really much. Compared to 7.
Yes, but I think they're also talking about doubling that across time. I think that will be the starting point.
Yes, one more question. Niklas.
You mentioned that if you need to go from 75, that is for the lead to 65, you need a ventilation system. Isn't that traditional in all houses, the ventilation system? Or what do you mean by that?
Yeah, by ventilation, I mean forced ventilation. So, no, in many US houses, they are so leaky that you haven't required forced ventilation. In commercial buildings, yes, you require ventilation. But in most homes, most US homes that were built before 1960 were not built with air conditioning or heating. They were not built that way. They were built unheated. And so they weren't built very tight. And so as you make them tighter, you get to about that point where you have to add mechanical ventilation to the houses. So air quality is a big problem in US houses.
Yes, that's a good step to take for you if you have the ventilation and also heat recovery.
Well, that's the next thing, and our friends from Four Systems here, big market opportunity because suddenly you have to ventilate. You don't want to ventilate when the outside temperature is 90 degrees Fahrenheit and 70% humidity, as it is in the south. You need to recover all of that heat on the way out.
We have the same problem, but...
And the other way around with the heat.
Yeah. Something else?
You use a lot of air equipment, for example, heat chillers and heat pumps and so on. And there's very less going on in ground source energy. What's going to be done about it in the near years?
Yeah, I think it's going to be interesting to see whether either district heating and cooling will end up being the predominant way to go, or air handlers. What's happening at the moment is that the building codes are increasing every year the required minimum efficiency of the heat pumps. There are people putting ground source in, but the problem is the cost of doing that when your electricity is only 10 cents per kilowatt. I mean, yeah, you save the money, but it may take you 20 years to get the investment back. So I think what they're doing is just driving up the energy rating each year of the traditional systems. Thank you very much.
Okay. I have one more question, Ross, if nobody else has a question. Yes.
Yeah. Yeah. What is it? A gross domestic product. So it's the amount of dollars a country produces in internal consumption and exports. So it's really a measure of sales. What is the country making and selling as a whole country? So when you look at those graphs and you see, in the case, say, of Holland is around $30,000 US. So what that's saying is that each year the country produces the average of $30,000 US of product for each citizen. And the US is about 38. But Holland produces its 30 with half as much energy as the US produces its 38. So we make it, but we're not making any money on it. You know, it's becoming more and more expensive. We can make a lot of it, we just can't make any profit, which is not the best business model.
No, it's ineffective.
It's very ineffective.
One thing I thought about here in your presentation, you said about these federal requirements you were talking about. Are they new? Or how old are they?
Yeah, the lead requirements, they probably started developing them about 10 years ago.
Okay.
But as you could see from those graphs, it was about 5 years ago that they started to take off. And the reason they took off was because the price of electricity went up. Yeah. And suddenly people said, I really have to do this because my cost of energy is going to double. Yeah. I better do something.
In the Energy Star system, do you make difference of heat and electricity?
No.
It's the same?
It's the same.
Same kilowatt hours?
It's kilowatt hours, BTUs, however you measure it, but it's total. Yep. It's the total number.
Oh, okay. Yes. Yes, one last question.
How does the building company prove he meets the requirements?
Yeah. There are a couple of different ways. Because this is not a law, there are two ways you can do it. You can just do it yourself, download all of the information off their website, and you can rate it yourself, if you're interested in how you think you're going. If you want to publish that information, though, it needs to be independently verified by a third party who is approved. And so both for the Energy Star rating and also the LEED rating, there are individuals and companies that are auditors who look at your information and will check to see whether it's correct. And it costs. It's not free.
Okay.
Audit just on paper, or are they also measuring?
They're measuring as well. Yeah, they will. If you are certifying many buildings, if you're an architect firm, if you're doing many buildings, they might come and measure 10%. Or if you're building, say, 1,000 units, they will come in and measure 10%, but they won't tell you which 10% they're going to measure. Okay. And if you fail one, you fail all. So it's quite rigorous, and it's third party.
Okay, we need to stop here.
Yeah, but I'm happy to take questions later.
Thank you very much. We can take questions later, and Ross says. Now it's time for a coffee break.